All right, everyone. Hello and welcome. My name's Aurora. I'm with the Central Coast Astronomical Society. We have a number of astronomers that are on tonight, and if you are joining us, if this is your very first time, I want to extend a special welcome to you. We have so many fun surprises for you tonight. Okay, I think I got it all. I got prizes, I got maps, I got star charts. I think we are ready to go. So you ready to meet our astronomers? Okay, so the first astronomer we're going to meet is actually outside in the cold. So let's bring him on. So hang on a second there, Kent. We actually have an astronomer. He's actually a member of Riverside Astronomical as well as Central Coast. His name is Brian. I don't even know if he's actually here, but here's a picture of him and his telescope that we're going to be looking through tonight. And he's actually inside right now. Okay, let me give you a live view of Brian. Hang on just a second. Let me grab him for you. Hey, Brian.
Hello. Yes, I'm actually nice, warm and toasty inside, but my telescope is outside, ready to go.
Awesome. Wonderful. So we have a number of objects we're going to be taking a look at tonight, huh?
Absolutely. Yes,
Okay.
I have the up. I'm ready capturing the first one here right now, so I'll send you a note as soon as it's ready to go.
Oh, that sounds awesome. Okay, thank you, Brian. Awesome. Okay, great. And so our other astronomers, I'll introduce them to you as we go through because a number of them have given us images we can share with you tonight. So I'm excited about that. Okay, ready? Okay, here we go. Our main astronomer for tonight giving us a tour of the night sky. His name is Kent, and Kent Wallace, and he first got his telescope. Kent, are you there?
Yep, I'm there.
Hi, Kent. So I've got a picture of you right now with an orange telescope.
Yeah, that's my old C8 from my backyard.
Wow. And so that was a good telescope for you to get started with.
Excellent scope. Real easy to set up, easy to pack up, tripod's easy to move, and they had tons of accessories that you could buy for it. So it was a real good deal. I got it in the early 80s,
Nice.
before Halley's Comet came in, and there's just a lot of good stuff available in terms of eyepieces and various equipment.
Awesome. Well, welcome, Kent. So Kent's been doing this astronomy thing for a long time, so he's going to be taking us a tour on the night sky. Now, he actually doesn't have star charts in front of him. A lot of this stuff, it's just from his head, just because he's done so much stargazing, like in the field. So please, just sit back, enjoy. If you're brand new, I totally welcome you. Just sit back, enjoy, relax, enjoy the show. If you have questions, you can pop them in, but just enjoy learning as much astronomy as you possibly can. All right, Kent, so you have a bigger telescope now, right?
Yeah, I've got a 20-inch reflector. There you got the pictures of it, and you can see the mirror in the box to the right there. And I got that about 13 years after I got the 8-inch scope, and it opened up a whole brand new universe. Everything looked, a lot better. You could see color in objects. You could, go down about 2 magnitudes deeper visually. So yeah, it was really really nice. The only problem is it's really a pain to set up and tear down. Takes about 45 minutes either way.
Wow.
To roll it out of the back of the truck and put everything together, and then when you're tired and cold and late at night, then you gotta tear everything down and haul it back into the truck.
That's when you're tired too, right?
Yeah, the views are fantastic.
Yes, they are. And that's what we're going to share with you guys tonight. So we are going to do all the heavy lifting. You guys don't even have to set up a telescope tonight. Okay. And so, so we are going to go ahead and get started. We're going to show you where to find things. I'm going to teach you how to star hop so you know exactly how to know where to find these things. So his first thing he was talking about was Mars. We covered the Pleiades last time. A lot of people can't, what do they think when they first see the Pleiades for the first time? What did you think?
Actually, I thought it would look like a little dipper. It's got a short handle on it, but it does look like it has a bowl there. This is before I'd learned the constellations. I was going like, that must be the Little Dipper, because it was so obvious.
Yes. So if we go out in the sky tonight and you walk outside, and again, we are in the northern hemisphere for looking right now, but that is going to change tonight. So we are looking west, and really, if you just look straight up, you're going to see.
Yeah, you got Mars there, you got Aldebaran, and you got the Pleiades. And one other thing is, your program is showing The previous image where you saw the western horizon, I could see what looks like the zodiacal light. See how it gets brighter? You got those isophants or whatever of brightness from the west. You got the red W there, and just to the right of it, there's like increasing brightness leading up towards the Pleiades, and that's called the zodiacal light.
Tell us about that.
This time of year, it's pretty visible. And, you have to have a clear, dark western horizon. You go out just after dark, and there'll be a faint cone of yellow light kind of reaching up from the horizon towards the Pleiades. If you're in a good dark area, and it's this time of year, it's quite noticeable because it follows the ecliptic, and the ecliptic is at a good angle right now. It's actually caused by dust in the plane of our solar system reflecting sunlight. They say it's probably, the dust is probably due to, collisions among the asteroids. Over, billions of years, you generate some dust. And it's also interesting to compare the color of the zodiacal light, which is yellow, with the winter Milky Way, which is more up higher, actually, where the winter Milky Way is white. And you can definitely see the color difference there.
Oh, wow. That's amazing.
Yeah, you can see you got the Milky Way there to the northwest, but also it continues on up. It's easier to see when it's up by Orion and Sirius, and that part of it. See how it's brighter towards Canis Major, all of that. It definitely looks white, where the other, in fact, even on your screen, it looks whiter than it does if you look at the zodiacal light. I don't know if they have some color built in for that or not, but you can see that glow.
Yeah, you can see it. Oh, that's awesome. So just to really quickly reiterate, because I know we're gonna hit a lot of things tonight. So if you can find, do you mind if we look at the winter hexagon really quick? There, Kent.
Oh, right now I'm seeing Brian's picture of the Rosette Nebula.
Oh, you gave it away!
I may have blown it, but that's all that was on my screen.
Oh no! So Kent doesn't have a camera.
Yeah, everything went away except for Brian's picture.
Oh no, Brian, you can fix that, right?
I can see you now, but
yes, I fixed it.
I lost the graphics.
Here, I'm sorry. I was trying to get it all ready to go, and
no problem.
Replaced
no problem. And actually, the first time Kent was on, he didn't see anything I was showing you guys. He was doing it all from memory because we hadn't figured out how to get him in the loop of seeing what we were showing you. So he can do it all. Okay, so we're back here. So just real quick, we covered this last time, but the winter hexagon, most people can find Orion because those 3 belt stars are real bright. And
right, you've got the belt stars. Then you've got the sword, which has Orion Nebula in it. You can see that in the graphics. But for the outer rim of the great hexagon, you've got Rigel, which is in the foot of Orion. And then if you go clockwise, you jump over to Sirius. Well, you're going counterclockwise, but there you go. Clockwise, you got Sirius there. And then you jump up almost straight up, and there's Procyon for the little dog. And then you kind of jump around a bit further, and you got Castor and Pollux, which are the 2 twins for Gemini. And then you switch over to the kind of like the northwest, and you've got Capella, which is in Auriga. And then you drop back down to Aldebaran that we talked about earlier, and that makes up the great hexagon. And then right in the center, roughly, is Betelgeuse.
Yes, exactly.
Which is, Orion's such an easy one to find.
It is. Because
of the shape there. The 3 and, the belt stars are about the same brightness and about the same separation in a straight line. And then the outer stars like Betelgeuse and Rigel, and I forget the names of the other ones that are fairly bright, form like a rectangle around the belt.
Awesome. Perfect. Yeah, thanks for recapping that from last time. Okay, so the first thing we want to take a look at is the unicorn. There's a unicorn in the
Right.
sky. Did you guys know that? We have a unicorn.
Monoceros, or the unicorn. It's a modern constellation. Unicorn means one horn from the Greek, and this modern constellation was created by a gentleman of the name of Petrus Plancius in 1612. Some of the older guys, they tried to fill in the holes between the ancient Greek constellations, and so this guy made up Monoceros, and it stuck. And so now it's one of the 88 constellations that we have.
Perfect. And we can find it. If we can find Orion, you can find it. It's right next door.
Yeah, there's no really bright stars in it. It's kind of pitiful, but if you got a star chart and a pair of binoculars, you can work out the outline to it.
Right. Perfect. Okay, great. So do you want to tell us about the the nostril here?
Yeah, the rosette. It's it's a combination. The Rosette Nebula is an open cluster plus an emissions nebula. It's really an area where stars have been born. And the easy way to find it is to get the two shoulder stars, Betelgeuse and the other shoulder star, draw a straight line, and it pretty well gets you in the area. And when you look in there with binoculars, you should see the open cluster in the center. There's actually an NGC number for the open cluster. It's 2244. And the surrounding nebulosity was found piecemeal. So it's got a bunch of NGC numbers, so I just kind of avoided that. It kind of confuses the issue. But, this area is where you've got a cluster of young stars that have been born about 3 million years old. And they're blowing a hole in the center of this nebula. And I think the reason they call it rosette is because some of the photographs, you see the red hydrogen showing up really well. And, the open cluster is pretty much in the center.
Nice.
The cluster has a visual magnitude of 4.8 and a distance of 4,900 light years. It was discovered by William Herschel on January 24th, 1784. It's about 24 arc minutes across and contains about 100 stars. And it turns out the brightest star in that cluster actually doesn't belong to the cluster. It's a foreground star.
Oh, no.
It's been given the number 12 Monoceros and is not an actual member of the cluster. It's just in front of it. There is a seventh magnitude star in the cluster, which weighs about 50 times what our sun does and is roughly about 1 million times brighter.
Oh, wow.
So, the hard ultraviolet is pouring out of that, and it's just kind of pushing the nebula away from where they were born. Eventually, several million years in the future, there'll just be a nice little open cluster there, and you won't see any nebulosity. Let's see. Oh, also under dark skies, you can see that group cluster in the center, NGC 2244, with the naked eye. It's just you've got to have a good dark sky. It'll be seen like kind of like a fuzzy star.
Oh, okay.
There. And the nebula itself is quite large. It's about 80 arc minutes by about 60 arc minutes. You can see the emission nebula in an 8-inch scope. An O3 filter helps it stand out. In my 20-inch, you can actually see the dark lanes running through it. There's a few places there where you can see little dark lanes running around. But that's cheating, using a really big scope.
So what do you think about this image?
This is a nice image. I mean, you can definitely see there's like 6 fairly bright stars right in the center that are spread out kind of like an elongated rectangle. You can see the nebulosity there. I can see some of the dark lanes in it. So that's a nice image of the rosette. And you can see the size of it. And so, yeah, that's a good image there. It's, it's not a super bright nebula whatsoever. So
No, and the reason some people are asking why is this so faint? This is a live image right now. So this isn't like the beautiful pictures where you can play with them in Photoshop and stack the images. This is like this is a special camera that Brian, I'm sure, will tell you all about, that he's looking through right now, or he's got hooked up to his computer right now. So you are looking through the telescope, basically.
Right, if you could do like a long-term exposure of like, a couple minutes or a half an hour, you get all sorts of detail, a lot more red. But yeah, live, this is really great for live.
Yes, it's amazing for live. Brian, you want to tell us anything about it?
Sure. Well, so this image is a stacked combination of 69 images, actually. So it's a total exposure of 11 minutes.
Oh, wow.
A little over 11
Oh,
minutes.
okay.
And so I have the little program does what's called live stacking, and that helps to clear out some of the noise. And you'll notice it is a little foggy. Most of that's from light pollution. And if we were to save these images and then process them with some programs after the fact, we have some tricks to clear that out. But I'm pretty happy with this live view.
Yeah, that's gorgeous.
Yeah, it is. It is really nice when you can actually see the dark lanes in the nebula. You know you're doing pretty good.
Yes.
Awesome. Well, thank you. Good job.
All right. Excellent.
Okay,
Thanks.
let's go
I will
ahead
move on to the next one.
Yes, please do. Do as many as you can. I'm sure if you guys like this, let Brian know in the chat. So he's the one that's going to be that's helping monitor that. Okay, so what about the next one, the open cluster with the emission?
We've got NGC 2264, which is a combination open cluster and emissions nebula.
Okay.
And we still got the rosette there.
Yeah, let's just go up.
There you go.
There you go.
You've got the open cluster with the nebulosity around it. And the open cluster is called the Christmas tree cluster, believe it or not. It's like an outline. You've got a bright star in the base, and then it spreads out, and then it kind of goes to a point near the Cone Nebula there.
So Ken had to describe this because I did not see the Christmas tree at first, but it's upside down, and the top of the tree is here, and it's the outline of the nebula that's a triangle, and it kind of looks like an upside down tree.
Yeah, it's a weird open cluster in that it's an outline of an object. It isn't like all piled together in a nice little condensed thing.
Yes.
This is actually spread out. It's just the outline. This gentleman by the name of Leland S. Copeland called it the Christmas tree cluster in the 1954 March issue of Sky and Telescope, and the nickname stuck. And so that's always nice when you get a nickname that everyone agrees on and it's used.
Yes.
William Herschel discovered this cluster on January 18th, 1784. The cluster's got a magnitude of 3.8, so that's pretty darn good.
Yeah.
It's about 40 arc minutes across. It's 2,600 light years out there, so it's out there quite a ways. Has an age of about 20 million years, and then surrounding the Christmas tree cluster is this great big faint nebula that we see there.
Mm-hmm.
And William Herschel actually saw some of it on January 26, 1785. So in the next year, he picked up on the nebulosity around the Christmas tree. But I'm sure he just saw the brighter portions of the nebula, nothing like the photographs that we have. A portion of the emissions nebula just west of the base of the Christmas tree was given a modern name, Foxfur Nebula. I think due to the texture, some people took some really good photos under excellent conditions, and you can see almost like a furry texture. And it turns out the gentleman that created the NGC numbers, he just gave the NGC number of 2264 both to the open cluster and the nebulosity. So you get like 2 for 1 there.
That's awesome. And then the Cone Nebula.
Now, the cone is a toughie. I
Yeah.
mean, it's something you know, if you have super good conditions, it's a dark nebula. It's just south of the very top star in the Christmas tree. It's aligned roughly north-south, and it's about 5 arc minutes long. Isaac Roberts discovered the Cone Nebula on a 3-hour photograph taken with a 20-inch reflector on February 13th, 1895. This dark nebula is mainly ignored by the major catalogs. I couldn't hardly find anything about it until I went on to Am Astro and had about a dozen people from all over the world jump in with little bits of information. And in fact, the position of the Cone Nebula in the professional database, which is called SIMBAD, it's way off. It's up near the base of the Christmas tree.
Well, that's what you said. It was way over here. They thought it was here.
Yeah. They had a position way up by the base of the Christmas tree, so it's almost a full moon away from the actual cone. And so I guess whoever put the coordinates in there never looked to see what was there when they put in the coordinates. But there is one catalog that it may have shown up. Beverly T. Lynn's cataloged the Cone Nebula as Lynn's Dark Nebula number 1613 in her 1962 catalog, and that's a maybe. It's just about the only dark nebula near the position that she gave. She was actually a little bit west and a little bit north of the cone, but the positions are fairly crude in papers in the 60s. So, you can't complain.
No,
She probably got it right. But hers is like the only number for catalog. Doesn't have a Barnard number, which most of the dark nebula have. There is a report of the Cone Nebula being seen in a 10-inch reflector at low power, and it also, an O3 filter is said to make it stand out better. That was by Sue French. I don't know where she did that. She's a contributing article writer for Sky and Telescope. She wrote a whole mess of neat little articles about sections of the sky and what deep sky objects you could see. And I think she's got 2 books out on deep sky objects that were, I think, published by Sky Publishing, which is the Sky and Telescope people. And so she's seen it. You want to go on to the next object?
I didn't know. I had a hard time finding this binary star. So
yeah, this is kind of tough. You start with the bright one at the base.
Okay.
And you go to the bright one that's the tip of the tree right there. And then you go about equidistant, and there's one kind of bright star all by itself there. And that's called Sigma 953. It's a binary. It's you've got a magnitude 7.1 and another one at 7.7, and they're about 7 arc seconds apart, which is easy to split in like an 8-inch scope. And I couldn't find any historical data, but the Sigma binary stars or double stars is a guy by the name of Struve. Back in the 1800s, he found a bunch of them. And so it's got a Struve number of 953. And the interesting thing, it's a nice point to jump to our next object, which is Hubble's Variable Nebula, which is kind of a toughie. It's actually kind of west-southwest of Sigma.
Let me put the box around it so everybody can see it easier. There we go.
Yeah, I could just see it. It's like a little fan-shaped nebula. It's really cool. It's called Hubble's Variable Nebula, and I believe the star that's embedded in the tip of it is R Monoceros. Yeah, you can see how you make that jump down.
And then
and so if you can find the Christmas tree, you go to its top, you go to that nice little double star, then you swing southwest, and you've got this little cone-shaped guy. And William Herschel actually discovered this. They call it NGC 2261 on December 26, 1783. It's a small fan-shaped nebula with a visual magnitude around 10 and the size of about 2 arc-minutes by 1 arc-minute, and it's about 2,500 light years away. Edwin Hubble discovered the variability of this nebula in 1916, so that's where we get the Hubble's variable nebula.
Wow.
It's about the distance from that Sigma 953 to Hubble's variable nebula is about 33 arc-minutes, so it's a little over a full moon.
Okay.
Oh, you got it? Is Brian? Oh, cool.
Look at him. He got
Brian
it. Do you
got
guys
it.
see that?
And it's actually, it shows up easily in my 8-inch telescope at low power. And it can change very rapidly, as short as a week. You know, they'll take photos of it, and just like a week apart, you can actually see changes in the shape of the nebula.
Wow.
But that's great. Good job, Brian.
Nice job, Brian. Do you want to tell us about this one?
Thank you. This one, it's funny at first with my view, this is a much smaller object than the rosette. So if I show you the full view from my camera,
Oh my.
here it is, this little cone
Little
shaped
fan
fuzzy.
shape, it almost looks like a comet.
Yes. and so that's one of the reasons I love this camera is we have enough resolution where I can then simply increase the percentage that I'm showing you, and allows us to zoom in and see some good detail.
How long are
Yeah,
your
that's-
exposures right now?
Right now, these are 5-second exposures, and this has been just stacked 4 times.
Oh, wow.
Okay, so that's 20 seconds.
Yeah, not too bad.
That's great.
That's amazing.
Yeah, I mean, I get the feeling that, that number of 10th magnitude is probably off. I think it's really brighter than 10th magnitude.
Yeah.
I don't know how they come up with these numbers, but it's not that hard an object to find in my 8-inch. I just use that Christmas tree. Oh, there's a neat one. That's a Hubble.
Yeah,
shot
well,
up there.
you don't want to show this first. You show this last.
Yeah, when you can see details in the nebulosity, then usually you can blame Hubble.
I know. I couldn't resist. This one was so pretty. I just wanted to throw it in.
Now, what would be nice if they took a bunch of them in Hubble week to week to week, and you could really see the changes occur. I don't know. Maybe they've done that. I don't know.
That's a good question.
But it is kind of neat that Edwin Hubble, did that. They named the Hubble telescope after him, and this is Hubble's nebula.
Yeah, that is really cool. Okay, so just to recap where we are in the night sky. So most people can find Orion, just look for those 3 belt stars, and then go from armpit to armpit and extend that out about the same, and you'll see the rosette that we saw first, the Rosette Nebula in here. And then if you just go up, you'll actually see the Christmas tree. In here, probably not the cone, as Kent said, it's pretty difficult to find. But you'll see the Christmas tree, the top of the Christmas tree has that really bright star. Then see if you can find a bright double. And then you're going to go a little and make almost, it's not quite a 90 degree, a little bit. And then you should see something that looks faintly like a comet. So yeah.
That's pretty close to 90 degrees, isn't it?
It is. It actually is pretty close. Okay. Yeah.
And
nice.
that other nebula that keeps popping in?
We have no idea what this is.
I have no idea what that is. I mean, I've never seen it before. It may be a faint reflection nebula or something like that. Monoceros doesn't have a lot of really good guide stars in it.
No,
so,
it doesn't.
It might be a neat thing that I've just never looked at.
Yeah, and again, you're not going to see these pretty, labels in the sky. So just to kind of give you okay, this is what it's going to look like. When you go out tonight, you're going to be looking west. You'll look up. You'll find the Pleiades. You'll see Mars. And then you'll kind of look more to the southwest. And then you'll see those 3 belt stars. And then you'll go from armpit to armpit. And you can actually see it here. and hit this area, go up to find that other object we were talking about, the Christmas tree, and then you'll see the variable Hubble's variable right in here, so you can kind of see it. So yeah, we don't know what this is. This is not something that we're familiar with, but if you have, feel free to put it in the chat so we know. Okay, so moving on, we have an open cluster you were going to tell us about. That's on the other side.
Right. This is in, previously the stuff is in northern Monoceros.
Yeah.
We're going to go down to southern Monoceros for an open cluster. It's a Messier object. It was actually discovered by Giovanni Cassini of Cassini division fame, I believe. It was discovered in 1711. Charles Messier independently discovered this object, this open cluster, on April 5th, 1772. So, a little over 60 years later, he didn't know about Cassini's discovery. M50 has a visual magnitude of 5.9, a size of about 15 arc minutes across. It's about 2,870 light years distant. It has about 80 member stars in it, and it's about 100 million years old. It's also a binocular object. All you do is kind of start at Sirius and go up from there, up and over.
Here, hang on. You beat me to it. I thought you were going to tell me a little bit more about it. Okay, here we go. Sirius, super bright star, super easy to find. Orion's main dog, right? So the belt stars kind of point straight to Sirius. You can't miss it. And then where do we go, Kent?
Okay, then you go up towards the head of it, and then you got to pull I usually pull out my binoculars at that time.
Yeah, here. I was really
there
close.
You go. It's actually right near a little nebula. I think that's called the Seagull Nebula there.
Yeah.
And I think it's just inside the border of Canis Major.
Yes.
But anyhow, you can see this little guy there. So the place to start is Sirius, and then work your way up, looking for an open cluster in your binoculars. In fact, the nose of the dog there, you go Sirius nose, and then about equidistant, isn't it?
Yes. Here, so we'll take
so
off
that
all the
maybe
labels.
is one way to find it.
Yes. So we've got the three belt stars point straight to Sirius, and then you've got a little bright star here that's the nose, and then you can see this object. Good job. All right.
And so that takes care of Monoceros.
Awesome. Okay, so we are on to our next constellation. So here, I'm following along in our handout as well. So tell me about the Argo. What happened to the Argo?
Argo Navis means the ship Argo, and this is an ancient Greek constellation. It goes back to Jason and the Argonauts. That was their ship that they traveled on their voyage to get the Golden Fleece. And it was broken up into three modern constellations. It was so big and it covered so much stuff. This French guy by the name of Nicolas de la Caille in 1752 split it into three pieces. The front part, which is this, actually it's the back, the stern, is Puppis. He broke it up. They call it Puppis, which is a stern, which I believe the stern is the rear end of the ship. And then another section he broke into Vela, which is the sails. And then the very last piece was the Carina, which is the keel. And evidently they liked how he broke it up, because we have it today. But it's kind of weird. I don't know if in the old pictures whether they show the rear end of the ship disappearing. Usually would show, if you had a ship, you'd show the prow of it, with the figurehead. Yeah. And in fact, didn't it have like a carving of Athena or something like that?
Yeah, that's right.
I don't know. That's from the old movies, the Ray Harryhausen movies. But it's kind of weird that they showed the rear end of the ship. Maybe they're going somewhere.
It is strange.
But it's like the only of there's 48 ancient Greek constellations. and it's like the only one that really got busted up like this.
Yes.
And so it's still there. It just was kind of too large. It drove them crazy.
Yeah. Well, that's okay. So which one do you want to do first? You want to do Puppis?
Okay, we'll go with Puppis.
Okay.
The stern there.
Let's go check it out.
It's a modern constellation. It's kind of towards the south, although there is a part that sticks up near Sirius, and we've got our first object in there, which is M46. So I don't know if I'm jumping the gun, but you have to go up to pull in Sirius, and then the easiest way to find M46 is you got Sirius and see the front paw. There, draw kind of a line from the front paw through Sirius and continue outward, and there's kind of like a fuzzy thing there.
Yeah.
And that's M46.
Let me put the little box around it. Whoop,
actually, that was M47. I'm sorry, but there is a fuzzy thing right there. It is.
There it is.
It's a really beautiful visually, really a beautiful open cluster. Charles Messier discovered it on February 19th, 1771. It's got a visual magnitude of 6.1. It's about 20 arc minutes across, and it's about 4,480 light years distant. Has about 500 members and an age of 500 million years. The interesting thing about M46 is all the member stars are about the same brightness. There aren't any really super bright ones or super dim ones. And so it makes it look really neat.
Yeah.
And then also, what you're showing there is there's a planetary nebula.
There it is.
That it may be a member, it may not be a member. It depends on whose book you read.
Oh, great!
But it's called NGC 2438. It's on the northeastern side of M46. And yeah, I've heard it both ways over many years. So no one's really nailed it down whether it's a cluster member or not. But it is really pretty. It's a twofer. You get M46 and you get the planetary nebula there. William Herschel discovered this planetary nebula on March 19th, 1786. It's got a visual magnitude of around 10.8, and it's about 66 arc seconds across. In my scope, it has a nice roundness to it.
I was just going to say, how big of is this a binocular thing? Is this a telescope thing?
It's not a binocular object, but it is, if you have like an 8-inch scope, an 8-inch scope will show it really easily. M46 itself, the cluster, shows up fine as a, nice round kind of little cloud there. In let's say my 750 binoculars, and at low power in my 8-inch, it's really pretty. You've got all those little stars about the same brightness.
Yeah. Oh, now you've got people asking, "Where's the planet?" Do you want to maybe answer that question real quick?
Planetary nebula have nothing to do with planets, but if you look at the photo of that, there's a disk there, and William Herschel is the guy that called them planetary nebula because they showed a round disk, like a planet shows, so they look kind of like planets in their appearance or the geometric shape of them. Right now we know there's a lot of weird ones, but a lot of them are just round and have like a sharp edge on them visually. And so they just called them planetary nebula. And that goes all the way back to the 1700s when William Herschel invented a lot of this nomenclature.
Now, their telescopes back then were small, so they didn't know it wasn't a planet.
Well, actually, William Herschel had really big honking telescopes.
Well, except for right.
Yeah, he was the first guy to go like big Dobsonian type stuff.
I should get a picture of that out so you guys could see it.
I mean, where Messier found 100 objects. Or actually, he also brought in a lot of objects that other people found. He put in his list. William Herschel found like 2,500 deep sky objects.
Wow.
His son went down to South Africa with a scope that was very similar and found another 2,500 or so. So a good portion of the original New General Catalog, or NGC, are objects found either by William Herschel or his son John Herschel.
Oh, wow.
So there's quite a bit. Herschel's kind of like the man. He built his telescopes, and he built some of the largest and best ones, and the mirrors were metal, which is really bizarre. Yeah, it was a mixture of tin and some other junk, tin, copper, etc. They call it speculum. And the problem with metal is it tarnishes. So they would have to refigure their mirrors over and over and over again.
Oh, my.
As they tarnished, maybe a couple months it'd be good, and then it'd get all tarnished, and you'd have to clean it up. And so, the whole astronomical history about William Herschel is really something else. He found the planet Uranus. That's the thing that got his fame started. Then he became the astronomer to the king, so he got enough money from the king so he could quit teaching music. And then he actually discovered infrared, which is something. He had a spectra. He had a what do you call it? A prism, and he broke up all the colors of light, and he was measuring the temperatures of the different colors of light with a thermometer, and he kind of rolled it off the red side, and it still registered. And he realized that there was something invisible that was dumping energy out. So he discovered infrared rays that we can't see.
Oh, wow.
So there's a lot to the guy.
Yeah,
there's quite a few different books on William Herschel.
Yeah.
But anyhow, I'm getting off topic here.
Yeah, let's go back to M46 and the neighbor M47. You want to do
the neighbor,
those two?
M47 is only like 1.1 degrees to the east and a bit north. And unlike M46, which is pretty well, they're pretty well even in brightness, M47 is rough. It's got, brighter stars and dimmer stars.
Rough.
And
that's not something you normally hear when you talk about light.
Yeah, or there's a term used which is a coarse cluster, which means that you've got brighter ones and fainter ones.
Yes.
And M47 is it's definitely a binocular object. It was discovered by Giovanni Herdonia in 1654. And we talked about that gentleman because he discovered those open clusters kind of up through the center of Riga. I think it was M37, M36, and M38. He discovered those three clusters. He was in Sicily, and he made a list that was lost until like 1985.
Oh, my goodness.
And so they found the list. They realized this guy had found a lot of deep sky objects, was never given credit. He found them way early.
Wow.
And so this one, actually, the credit goes to Holdernia.
Okay.
M47 has a visual magnitude of 4.4, so that's fairly bright.
Yes.
It's about 30 arc minutes across, so that's about the size of a full moon. And it's got an age of about 30 to 100 million years. It varies from who you believe. Got about 100 members in it.
Okay.
The thing I like is the coarseness of it. You've got brighter stars and dimmer stars, so it's kind of neat from that aspect.
Nice. So I was just going to say, just to kind of reiterate where we are in the night sky. So if we go outside, and here, I'll put my horizon back in.
The thing to do is look for Sirius first.
Yes.
That's the brightest star in the sky,
yes,
excepting our sun.
Right.
And there's actually a couple ways. You can go to Sirius, go to the front foot, which is fairly easy to see, then go backwards from the front foot, draw a line, straight out, and that gets you. If you hunt in that area with your binoculars, you will see M47 first, and then you'll see this little cloud off to the east from it, and that's M46. So that's kind of like a twofer.
Yeah, it is.
You throw in the planetary nebula, and you got a threefer.
That's true. That guy right there. Nice.
But
Okay,
it's a nice binocular object, especially with M47 being mag 4.4.
Yes.
That's fairly bright.
That is bright. Now we're going to give a shout out here to a member who took an image of the next object here. Let's see, Dave, where are you? Thank you, Dave. This is Dave Majors, who has been.
Dave.
Yeah, look what he took a picture of.
Yeah, that's neat. That's M93.
Yes, you want to tell us about it?
That's our next object.
That's our next object.
That's down further south from M46 and M47.
Okay. Let me put the box around it here. There we go.
Yeah, you see it's down quite a ways. If you expand out the field to bring in Canis Major, you can see that.
Okay.
It's kind of, you got the hindquarters, so you got Cirrus, and it's down a ways there.
So it's right above these two bright stars in Puppis, right? So here, if we take this.
Yeah, one. if you can find those two, which are the brighter, good bright stars in Puppis, you just take the dimmer of the two, or the western one, and just go up with your binoculars, and you should be able to see a fuzzy object there.
Yeah.
In your binoculars, you put it in your scope, and you've got a nice open cluster there.
I'm not seeing the butterfly in this one, but that's okay.
Yeah, people come up with all sorts of weird names, and that one I don't think is really. But can you get Dave's picture back up there?
Yeah, let's get Dave's picture back up. Nice job, Dave.
That's a good picture there. Yeah, those two bright green stars, those are the two orange stars at a different orientation.
Okay.
That you see in the
here
in the previous photo.
There they are, right there.
See those two there? Yeah.
Yeah.
But that's a good shot by Dave there.
Woohoo! Nice job, Dave! Yay!
Yay, Dave!
All right. So tell us about this one. The visual magnitude. How big is it?
You want to go for the other?
Yeah.
The next.
The open star cluster. 20,
let's see.
24.
I think I covered all the specs on, or did I cover all the specs on M93? I think I did. You got Charles Messier discovered the open cluster M93 on March 20th, 1781. Has a magnitude of 6.4, size of 24 arc minutes across, and a distance of 3,380 light years. Contains about 80 stars, has an age of about 400 million years. Yeah, I don't think I went over the specs, but those are the basic specs on M93. And the last object in Puppis is a really neat open cluster, NGC 2477.
All right, and it's totally in the other side.
And that's down a lot further south,
is.
but it's visible, from, easily visible out at Navajo Flats. And the nice thing about my old orange telescope is it's up on a tripod, so it's real easy to point towards low stuff.
Okay.
Where if you got my 20-inch out there, you're on your knees in the dirt trying to pull in the, because it's this long tube and you're looking, from the front of it. So it's a lot nicer to have like a telescope up on a tripod that you can point, to the low south to pull in objects.
Now, how were we star hopping to this one? So here, let's take all the lines off.
Okay, I guess first thing we got to do is get the picture up with Cirrus and all of that.
There we go. Here's Orion. Here's Orion's belt, and here's Cirrus. Okay, so now what do we do?
Okay, I'm getting no graphics. I see your face, but...
oh, my goodness. I'm so sorry. Here we go.
No, that's okay. That's okay now.
I'm so sorry. Here I am thinking that you guys are watching the Stellarium program. How fun.
Yeah, there wasn't any Stellarium. It's up there now.
That's okay. That's all right. It's bound to happen at least once. I have 4 or 5 different controls here. I'll show you near the end how crazy this looks. in order to coordinate all this. So sorry. Here we go. Okay, so here we go. Orion.
But you can see Canis Major really well.
Yes.
You've got, Cirrus. You've got the front paw. You got the head of the dog. Then you've got the back of the dog and that triangle that's the hindquarters.
Mm-hmm.
You can see this guy's, sufficiently below the hindquarters there, so it's down a little ways. And you can see there's one bright star there. Actually, there's like a triangle in there, but there's that one. Actually, there's two fairly bright stars there. And you can see where that little guy's lit up next to a star there.
Yeah, okay.
And the thing is, it's just such a beautiful open cluster. It was discovered by Nicholas Lacaille, same guy that split everything up. It's a rich open cluster. He discovered it somewhere between 1751 and 1753 from Cape Town, and has a visual magnitude of 5.8, a size of 20 arc minutes across. It's about 3,700 light years distant, and it has over 1,900 member stars and an age of about 1.3 billion years, which is really quite old for an open cluster. But you can see how it is. It's so cool that there's so many stars in that cluster. It looks almost like a globular cluster, but it isn't. It's actually an open cluster. And then off to the right and up, you've got another open cluster that's 2451, which is real coarse, versus 2477, which is real smooth.
Yeah.
But there's also some colored stars in that open cluster. So the 2451 to the upper right is kind of a pretty one.
It is. And I just have to tell everybody, that's not one we were planning to cover, and Kent hasn't seen this picture, so he just did that off the top of his head. Okay, nice. All right, so do you want to talk about the sails?
Yeah, let's talk about Vela, which is the sails.
Let's do that.
Again, it's a modern constellation created by De La Calle when he broke up Argo, the ship. Mm-hmm. And it's kind of like a loop of stars. And, it's getting down low, but still out at Navajo Flats you can see all of it. You just have to kind of wait till it gets up in the south. And the first object we'll cover is a planetary nebula, NGC 3132, which is also called the 8-burst nebula, and there's a more modern nickname, the Southern Ring Nebula. But the 8-burst one has been around for a long time. I think it goes back to concentric rings they saw on some ground-based images with telescopes. And this is a ground-based image you're showing there with the central star, or what looks like the central star, and you can see kind of like a few rings that are piled up there. This is a Hubble shot, and the real interesting thing about that central star that we thought we saw, there's a little star right next to it. And it turns out the bright star is 10th magnitude, where the little star is 16th magnitude. And that little star is the one that's causing the whole thing to fluoresce, lighting up that whole nebula. They were wondering about the 10th magnitude star, but it wasn't hot enough to excite all that nebulosity.
Oh, wow.
And until they got a good Hubble shot that showed this little faint guy, they're a binary setup. It just happens a little guy's, it's on its way to becoming a white dwarf someday. Exactly what's the dividing line between the central star of a planetary nebula and a white dwarf, I don't know. And I haven't seen a really good write-up, I get the feeling they're still, what is to be determined, or TDB. They're still working on that. But that's what's happening there in the Hubble photo. You can see that little faint companion. And that's the one that's doing the heavy lifting for the whole image. To me, it looks kind of like a pool of water around a geyser.
It does.
Or something like that.
It totally does. Let's show people where to find this one for real. So here.
Okay.
Okay, so we are...
We have to go back to the loop in...
yes.
In,
you can see here. Here,
Vela.
let's get something familiar to people. Okay, so there's Orion.
Okay.
And there's...
As you can see, it's down there a ways.
Yeah, and it's really close to the horizon, where at least where this program is set up. But depending on where you are in the world, this may be higher in the sky for you. Okay.
And you can see there's a star next to it. That's one of the stars in that loop that made up Vela.
Mm-hmm.
And you can see it's not too far. Yeah, see how you've got kind of like that loop of stars?
Yes.
And there's that one to the east there that it's right above that.
Yeah.
And the specs on it are that John Herschel discovered it on March 2nd, 1835. So he was down at Cape Town in South Africa.
Oh, wow.
And he found this planetary nebula. It's got a visual magnitude of 9.2, which is fairly bright. The size is 62 arc seconds by 43 arc seconds, and it's roughly around 2,000 light years away. The distances of planetary nebulas are really flaky.
Yeah.
So it could be twice that, it could be half that, you know. So that was the number in the book.
Okay.
With my 8-inch out at Navajo Flats, I was able to blink this planetary nebula through my finder scope, which is an 8 by 50.
Now tell me what you mean by blink.
Scope.
So I'm totally new. Tell me.
I was moving an O3 filter between my eyepiece and the front of the finder scope.
Okay.
And they call that blinking because when you put it in there, the little thing will pop in, and then you move it away and it disappears. Also had a dark cloth thrown over my head to block any incoming light. Yeah, this going back and forth, it's there, and then you move it away, it's not there. That's called blinking.
Okay.
And there was a gentleman down in Southern California who I can't remember his name right now, but he is the first guy to call the technique blinking. And yeah, I wish I could remember his name.
Oh, that's okay. I'm actually reaching over here for the filter. I have an O3 just in case people want to see what that looks like. Why don't you keep going though?
Oh yeah. Also,
Okay,
you know, it's not that hard out at Navajo Flats because it's fairly dark.
Yeah.
And an O3 filter really helps, although you don't need an O3 filter when you're looking through the eyepiece.
Perfect.
It also depends on how clear your horizon is. Out at Navajo Flats, the theoretical horizon is minus 54.5 declination. There you go. See how it's like a little mirror?
Yeah.
Yeah, that's why you have to throw a dark cloth over your head, because the starlight will come over your shoulder, hit the front of that filter, and degrade the image that's going to your eye.
Wow.
So, you know, I tell people when they buy, there was a lady at the Texas Star Party, she couldn't get her O3 filter to work.
Oh, no.
No one told her that you needed a dark cloth to block the light. She was trying, you know, she was going to sell it back or something like that. And I said, get a dark cloth or throw your jacket over your head or something like that. Then it will work, because I've tried at times using it without a dark cloth, and it's really hard.
Yeah.
And I know what I'm doing, and it's really hard.
Oh, I'm sorry. Go ahead. Go ahead.
Oh, I'm sorry. Anyhow, yeah, those filters are really effective. There's you know, 3 of them I basically use. I use an O3, H beta, and then a UHC, which actually includes the O3 and the H beta lines.
So tell me about this. He does.
Brian's got
What is
an open cluster.
He does. Which open cluster does he have? I'll give you a hint. You just talked about it.
I assume it's M50.
No?
No, is it the 24?
It is, yes.
77?
You did it. Uh-huh.
Oh, okay.
Nice.
It just, I bet you what it is, he has it expanded pretty good. Yeah. There's really a red star in there also.
Brian, you want to tell us about it?
Yes, so with this one, it's interesting trying to stack images where it's just stars and to see what I could bring out with the detail. But this is actually, because it's been working on it for a while, it's 30, about 30 images have stacked. But these are pretty short. These are all stars, so they're just about 4 seconds long.
Oh, okay. Yeah, there's one there that's really red. I just happened to notice. Yeah, that little guy there. Yes. I don't know anything about it, but it's really red.
Yes, it is.
Oh, that's cool.
Nice.
Can you actually what's it look like on an expanded field?
So
or do you have an expanded field image?
You mean where I can show you a more wide field? Or,
yeah, a wider field. I'm just curious.
Yeah, that's the widest I can go.
Oh, okay. Right, I was just curious if if you had a little bit wider field, we might be able to get 2451 in there also.
Right.
On there, but that's actually quite a distance because you don't even have that one star that's near the edge of it, so it's off the edge of your field there. Well, whatever popped up showing that red star now.
Yes, yeah, this is the view from Starry Night program, which is what I use to control my telescope. I'll go over to 2451 and maybe I'll let Aurora know if I can bring that one up to show you.
Oh, okay, cool. Great. That would be awesome. Thank you.
You're welcome.
Okay, great. Let me get my... Sorry, hang on, Brian. There we go. and yes, we have some questions about the telescopes that I have behind me. We will talk about those at the end. I promise. We will have plenty of time. Okay, so yes, people are wanting a link to the Messier Marathon handout. I was working on getting that up, but I haven't had a chance. So give me a second and I can get that up for you guys. And well, Brian, I'd rather have you do telescope stuff. So you do that and I'll get the
sounds good.
The link ready for you. Okay, so I believe we have a couple more objects. How are you guys doing? Are you guys enjoying this? All right, so for those of you who are asking great questions, thank you. Keep them coming. We'd love to be able to answer those for you. We've probably got another, I want to say, gosh, maybe another 15 minutes.
We got 3 more objects.
Yeah, we got 3 more objects. So, and then we can answer all the questions that have been coming in that astronomers haven't gotten to. So, again, this is Aurora with Kent and Brian from Central Coast Astronomy, and all our happy astronomers that are busily answering your questions. We are doing stargazing for the night sky. Just in case you popped in and said, "What is this?" Yes.
Want to go for the globular cluster?
Let's do the globular. Yes, here we go.
This is 3201.
Okay.
And it's about, right there is the 8 burst nebula, the planetary.
Mm-hmm. And we just
kind of drop straight on down. There's a fuzzy object there.
There is. Look at that. Here.
And
let me put the
that's our globular cluster, 3201.
Okay.
James Dunlap discovered this globular cluster in 1826. It's got a magnitude of 6.7, so it's fairly bright. It's about 20 arc minutes across, and it's got a distance of 17,000 light years. So for a globular, that's kind of close, but that's still a long ways if you consider the distances that we've been looking at for open clusters.
Yes.
It's about 7 degrees south and 1.5 degrees east of the 8 burst nebula, or the Southern Ring Nebula. Even though it has a declination of minus 46.5 degrees, it can be seen in binoculars from Navajo Flats as long as you don't have a lot of gunk near your horizon.
Perfect. Awesome.
And that's a really pretty shot.
Isn't that
yeah,
pretty?
that's what it's a Hubble.
Well, of course it is.
Yeah.
I thought you might appreciate that.
Yeah, that's there are some shots taken with the big observatories.
Oops, sorry.
Yes. Down in Australia that come close to something like that. And so anyhow, that takes care of Vela.
Yep.
Which is good. There's a lot more objects in these basic constellations.
Yeah.
We're just kind of covering the more obvious ones.
Yes.
Due to limitations of time and that sort of thing. The next constellation would be Carina, or the keel of the ship, which is the bottom of the ship. Again, it's a modern constellation. It's 1/3 of the Argo ship that was broken up. And the first object we're going to cover is a star, which is Canopus, which is the second brightest star in the sky. It's Alpha Carina, accepting our sun. It's 36 degrees south of Sirius.
Yeah.
So you can see Sirius up there. You can get an idea of the field of the graphic there. So it's 36 degrees. It's like magnitude negative 0.7. About 313 light years away. It's a yellow supergiant. It's 65 times the diameter of our sun and 14,000 times brighter. The declination of it is a little bit below minus 52 degrees in declination. And there's one place that I've seen it in San Luis Obispo County. If you go out on Road 229, which is a north-south road out of Creston, there's a buried water tank off to the side of the road. It's a BLM, Bureau of Land Management tank. And we used to have star parties out there. They called it Meteor Base. This is a long, long time ago. And you could actually see, if you look down the canyon, it had a really great southern view. You see Canopus just come up, move it away, and run into the side of a hill. And so you get a brief time of seeing Canopus. If you lived in Santa Barbara and you went down to the beach, they've got a great southern horizon out towards the Channel Islands. And so I'm sure they can probably pull in Canopus with a pair of binoculars, as long as you don't have a marine layer or something like that in the way. And the other thing would be go up into the hills behind Santa Barbara and look south.
What's so neat about Canopus? Why would I want to look at that?
Well, it's, for here in this county, it's like the most southern thing you can pull in.
Yes.
I mean, you're under 3 degrees from theoretical horizon. So that's besides being the second brightest star in the sky, it's just so far down there. And it probably is the most southerly thing that you can see from this county. So that's the neat thing about Canopus.
Nice. Okay, great. Now we have our last objects, and then we're going to, Brian actually has some galaxies to show you. So it's kind of a bonus.
Cool.
Yeah. So, all right, what's our next one on our handout here?
Okay, this is our next and last object. This is NGC 3372.
Okay.
It's called the Eta Carina Nebula. It's an emission nebula, and it's a starbirth region. And it's way down south.
It's super south.
You can see Canopus over there, and you go, and it's down around minus 60 something. But it's a fantastic object. I remember being down in Australia, as it's evening comes and it's starting to get dark. You can see that brighter wedge part of it with the naked eye, which is just amazing that it's that bright. It's kind of outlined by 2 dark lanes that are running through it. And it's the largest known H2 region in our galaxy. There are bigger ones in other galaxies, and there you got the really nice shot we were talking about.
Yes.
Where you can see the 2 dark lanes. There's one that's really obvious that kind of goes from the left to the center, and then there's not so obvious one that runs from center up to the upper right. But that really defines that wedge there. And it's easily naked eye. It's a fantastic object in a telescope. There's actually some open clusters embedded in there. But let me give you the specs on it.
Sure.
It was discovered, or actually first cataloged, by Nicholas de la Calle. He discovered it in 1751, or cataloged it in 1751. I'm sure other people had seen it, but he was the first to catalog it. It has a visual magnitude of 2.5 and a size of 120 arc minutes by 120 arc minutes, and it's 8,000 light years away. For comparison, the Orion Nebula is like, I think 1,300, 15 to 1,300. So this is 5 times further away, and it's an easy naked eye object.
Wow.
The only thing that beats it is like that NGC 604 in Triangulum we talked about, where if you pulled that out of Triangulum Galaxy and replaced it with the Orion Nebula, it would cover the whole Orion constellation.
Yeah.
That's far larger, but it's weird. For some reason, the H2 regions, or starbirth regions in big galaxies aren't large. Maybe it's the churning of the galaxy, the tidal forces. They're just not big. The two biggest that are nearby is that NGC 604 and M33, and also in the Large Magellanic Cloud, there's a big one called the Tarantula Nebula.
Yes.
Why that is, who knows?
Now, you were mentioning something in here of interest.
Yeah, there's actually two really neat things in there. There's that little kind of dark little elongated thing there right above the point, and that's called the keyhole. There you're circling the Keyhole Nebula. John Herschel coined that name. He made a bunch of, at least I think he coined it. He actually had made a bunch of drawings about it. And, a bit east of the keyhole, you can see a little star there. And that's actually the Eta star right there. It's a pretty wild object. It's magnitude 5. When you look at it in a telescope, it's like a dumbbell. It's got two lobes blown out from the star. And I remember the first time I looked at it with my 8-inch from Western Australia, one of the lobes was orange-colored, which really blew me away. The other one was kind of grayish. But, it's kind of funny. When they take ground-based photographs of this star, it looks like a little human figure, roughly. So they call it the Homunculus Nebula, or Homunculus. And... that star, something bad happened around 1843 to 1847.
Yes.
And they figured it came close to going supernova, but it didn't. Yeah, there you go. You can see the blowouts. In my 20-inch, you could see the ripples in the lobes.
Whoa.
And a lot of the details with that the Hubble telescope showed up. My friend Andrew Lockwood and I had a really good night. It was high in the sky, and we were just, geeking out over all the detail that was available. And so it's like one of the most unusual objects in our galaxy.
Wow.
And it's a good candidate to blow to Kingdom Come. Probably a lot better than even Betelgeuse.
Betelgeuse, yeah. That's awesome.
And that polishes it off.
Yay! Thank you so much, Kent. That was amazing. Oh, everyone right now, thank you. Put your hands on your computer and go ahead and type while we're going to go back to Brian and show you maybe we're not. Hang on. Brian's going to talk to us in just a second. And go ahead and let Kent know what you liked about tonight's presentation so we can be sure to do more of that tonight, or more of this next time. We don't go anywhere yet. We've got a couple of quick, more fun things we're going to be doing tonight. So, but yeah, go ahead and let Kent know how you enjoyed tonight's presentation and also for next time what you'd like us to focus on. So, okay, so Brian, what happened?
Oh, Aurora, clouds happened.
Oh, no.
Oh, bummer.
Yes.
That's okay.
Yes.
If those of you who enjoyed the views with Brian, also give him some kudos in the chat as well, so he can you can let him know if you've liked this. This is actually something new that we are doing, and we are excited to be able to bring that to you as well. Okay, so we are going to answer some questions. Brian, I know you've been like freezing outside, so I've got some questions that have come in that I thought we would give it a try to answer. The first one, let's see, how about Kent? Do you want to take this one? I'm a new beginner.
Okay.
I would like to get a telescope. Should I start with telescope or binoculars?
Oh, what was that?
The question
I'm
is,
sorry?
I'm new to astronomy. Do I need can I buy a telescope first, or should I start with binoculars?
I'd say start with binoculars. Get a good book. I like the H.A. Ray book.
Wait, I'm ready for you.
Learning Constellations. There you go. That's, it's still in print. There's a ton of used copies out there. If you go on like Amazon, You can probably find an older copy that's used. But the nice thing is it has stick figures of the constellation. There's lots of overlap. You can see the surrounding constellations. And so, it's a really good book. It's got 12 sky maps, with or without the lines for the constellation. It's a real easy way to use the binoculars along with the, the HA ray. And then also, you can make a red light if you have any nail polish. Take red nail polish, get a cheap flashlight, and just splash it all over the lens. And I've got a really crude old flashlight that I used back in around 1970.
I'm looking
that
for
I put
mine.
my mom's nail polish on. You want a red light because the red light doesn't cause your pupils to contract.
Right.
Where white light, you lose your night vision. And so, with the binoculars and the chart and the red light, you can, start somewhere like Orion this time of year and then learn the constellations around Orion. And it really makes a difference when you learn them by yourself. You're out there, just learn a few, look at the overlap. I really got into it. When I found Orion, it took me 3 months, and I covered everything visible from Visalia. But I had to stay up all night long to get it. But, I really got into it. So I actually covered all the stuff visible from my area using the HA Ray book. And once you've got the constellations down, that's the hardest thing to do.
Yes.
And then you want to subscribe to a magazine. They've got where the planets are for that month, which is really useful. That's really useful. You get that if you subscribe. In January it shows up. And that's in every copy. That shows you what's in the sky for that month.
Yes.
And so, either magazine is great. It keeps you up to par. And, it also, if you are really interested, do spend the time and, put a few hours on your binoculars, then you can make the decision to go for a telescope. But the best thing to do is, when this COVID stuff is ended this summer, go to a star party. Hopefully we'll have star parties. You can look through different people's telescope. You can ask them questions, ask them what they like about their scope, what they don't like about their scope. A big monster scope like mine, I've got a truck dedicated to that, where with the binoculars, you just throw them in the back seat.
Yes.
And some of the happy people that don't have to move the equipment have observatories, which is always nice.
Yes, I was going to give a shout out to Pete Bressler, who's been doing amazing work. He's got a new scope kit.
Oh yeah, I recognize some of those objects. He's got the rosette.
Yes. Down
in the lower left. The upper right is Thor's helmet that we talked about last month. To the lower right, we've got the Crab Nebula, and we talked about that 2 months ago. And then right in the middle there, at the bottom, that's the Owl Nebula. And I can't remember when we talked about that last. That was a long time ago.
Yes, that was a long time ago, and we talked about this one last time. This is Paul Wilson. He actually shot Mars and the Pleiades just with his camera. He stuck it on a tripod. Yeah, and he got a nice picture here.
Yeah, that's fairly recent, I think. Yeah.
Yes.
And then he's got the whole Orion Nebula there and the Running Man Nebula.
Yes.
And so, that's really a nice shot.
Yes, I've got a few more here from other members. Let's see, we've got that one, Lee Coombs.
Oh, there's Lee. Yeah, Lee's been doing astrophotography way back in time.
Long time.
I mean, he did black and white for the longest time.
Yes.
His pictures are in Sky and Telescope and all sorts of books going way back.
Yes. Oh, and Lee is going to be doing a special class with Central Coast Astronomy. He's going to be doing a class on the moon really soon. So we'll announce that. And so he would know what most people miss. And so he's going to do a complete tour of the moon from like day 4 or 5 to about day 11, 12. And so you want to make sure you don't miss that. So yes, so good job with Lee. And do you want to, okay, so we got the Pleiades here.
Yeah, that's a Pleiades there. That's the Helix Nebula. And then the one next to it's the Dumbbell, which can be seen real easily with binoculars.
Yes.
And that is the supernova remnant, one half of the Vela Nebula in Cygnus. And that's the easy one. I think that bright star there's 52 Cygnus. So you hit that star and you just kind of slide your telescope up and down the nebulosity there.
Nice.
But that's just one side. There's another side that's actually quite a bit larger. And so that's a really nice shot of a supernova remnant.
Perfect. And I got one more member who's submitted images. So this is Nikolai. He's been imaging the moon. He actually has a whole bunch in his AstroBin account. What do you see here, Kent?
Okay, the moon is really nice. You can see Sea of Tranquility, I believe, and I don't know what the other ones are.
That's okay.
I'd have to relearn it. He has the top photograph or astrophotograph there is Barnard's Loop. Those two bright regions that are inside of that curve. That's the Orion Nebula, and the other one is near the I think near the Horsehead.
Yeah, definitely.
Yeah, there's the belt, the Horsehead, and all that. And there he's got it blown up. You got the Flame Nebula. You've got the Sigma Orionis star, which is above the Horsehead there. You see that little multiple star?
This one?
We talked about that last month. And you can see the Horsehead, which is cool.
Yes.
It's just a little blob. And then you go over to the right and up, and you've got the Orion Nebula.
Nice.
So those are some nice. And look how the stars are mainly pinpoints. They aren't all weirdly elongated and stuff. I mean, that's the one thing about astrophotography is it's not easy because you have to track. And, I'm just amazed how these guys are. I get the feeling they've got computer programs that help them with the tracking.
I think they do.
Because it is not, no matter what, astrophotography is an art and it's difficult. But, I mean, it gives beautiful photos. So, the nice thing is now with computers and CCD stuff, you can do it at home.
Yes.
In the old days, I had a friend that took some beautiful comet photographs with the horizon and everything, and he went to like a 60-minute developer shop, and somehow they got hairs all over the photographs.
Oh, no.
And you had all these beautiful comet, I think it was Comet Hyakutake or something like that.
Oh, yes, I know that.
And you had hairs all over everything.
Oh.
They just really messed up the negatives. But that's a problem with having somebody else develop your photographs, especially someone that has no clue what an astrophotograph is.
Yeah, that is that. You kind of have to do it yourself. So.
Oh yeah, that's why a lot of guys went to in-home dark. What do they call it? The dark places where they take a bathroom and make it totally dark, and then have all the chemicals and things like that in baths to develop their own dark room. Develop their own photographs, which is an art in itself. And it's also got all these toxic chemicals you're dealing with in pans. So I've done a little bit of that, but it was for metallurgical stuff.
Was it this one that you were talking about?
No, it wasn't that one, because where they messed up was in the 90s, I think.
In the 90s, not that one.
Hyakutake was, it was the one just before Hale-Bopp came along.
Okay, hang on.
Which was, there you go, Hale-Bopp. That was like the comet of the century.
Yes, and then
you could see both tails. You could see the ion tail, which is blue, and the regular tail, which reflected more like sunlight colors. And so you could see that visually in a pair of binoculars quite easily.
Now this one's not going to come back until like the year 4,385 or something like that.
Oh yeah, yeah.
Did you see this one?
This is a beautiful look at the tail doing that.
Yeah.
I think that's probably a view from Australia.
Yes. I was just going to
That's
say.
definitely from Australia. Fantastic, multiple broken off sections of tail.
Yeah.
In fact, that may have been taken from Western Australia.
Mm-hmm.
There we go. Comet, there you got it. Aikitaki.
This is the one that had a tail that was over 500 million kilometers long, so it would span the entire horizon.
And it went right by the North Star, so it was just hanging there.
Wow.
Most of the night. I remember that, by the North Star. If my memory's correct, I think it did. It's the one that did that.
Yeah.
So it was quite a wonderful comet, and we had a wonderful comet in July, that Neil comet. There were some really nice pictures. How that multiple tail stuff. Someone got a picture, I think it was in Sky and Telescope, of the multiple tails. So at one time it had the multiple tail stuff.
Wow.
Which was really beautiful.
Wow, that's awesome. Okay, so we have a couple of quick questions here. One of them, we've got a number of questions about the mini marathon I announced in the beginning. So just to reiterate, I put the link in the chat box. So Brian, if you want to, you know what? I wonder if it's still here. No, it's not. Okay. I thought maybe it was still in my clipboard. So there are 20 objects. We don't need pictures. We trust you. You guys are on the honor system here. If you can find it without any go-tos, without any GPS, that's great. And as soon as you find it, just do as many as you can. You don't have to fill the whole thing out. Do as many as you can. And then these are due before our next stargazing event. So you have a whole month. So 20 objects. You can do like one a night. And then, that'll account for nights where it's cloudy, like we got clouded out for tonight. And then you're going to go ahead and submit this to Central Coast Astronomy. You can send it to me personally. My email is aurora@centralcoastastronomy.org. So Aurora, A-U-R-O-R-A, at centralcoastastronomy.org. Just go ahead and submit this, and we will put them all into, we actually have something for everybody, and then we'll put them all into a raffle and into a hat. And then I will pull one out at the beginning of our stargazing event next time in April. And Brian, when is our next event next April? I saw you were posting it.
Oh, I was, just mentioning that it will be on April 10th.
April 10th. Okay,
And
fabulous.
same time, 7 p.m. Pacific.
7 p.m. And since I've got you here,
Yes.
people are wanting to order like mugs and shirts. And
Yes, indeed.
Yes, you want to tell us about that?
We're building a store right now, Aurora, and so far we have one coffee cup ready to go.
Yay!
And so here's an image. This is an image of the Orion Nebula that I took last month. And so by the time I'm done, we'll have many different astrophotos, all submitted by Central Coast Astronomical members. And you'll be able to purchase t-shirts, mugs, even water bottles. So I posted the link for the store in our chat here. I'll put it up again, but I'll say it here too. It's redbubble.com/people/CCAS club. But I'll put it in the chat again, and we'll send out. And by the way, this is a good chance for me to remind people to subscribe to our YouTube channel, visit us on Facebook, and be sure to take a look at our website from time to time. It's centralcoastastronomy.org, and subscribe to our email list, because that's the best way to get up-to-the-date information on everything we're doing, including when we release more products on our store.
Perfect. Yes. So we are officially at centralcoastastronomy.org. And I just wanted to thank everybody that helped make this happen today. It's not just me, it's Brian, it's Kent, and it's everybody else that was submitting images and answering those questions furiously, because they come fast and furious, especially when we really get rolling. And so it's also Riverside Astronomical that we've been working with as well. So thank you all so much. I've gotten a couple of quick questions about binoculars. So Kent, I have my Looney Tune binoculars behind me. My husband calls them that because he's expecting like eyeballs, like in a cartoon.
Oh yeah, those are 100 millimeter across, aren't they?
Yes, they are. So do you want, if I say these are, what are these?
Those are 50s, aren't they?
Yeah, these are the 10 by 50s. And
10x
I say
50s, okay.
10x. And if I say these are 25 by 100, what does that mean?
That means that the objective, or the diameter of the lens in front, is 100 millimeters on the big ones, where on the small ones it's 50 millimeters. They always have, that's actually the second number. They usually have like 7x50. That one's what, 25x100?
Yes.
Something like that. So it's 25x is the magnification, or 25 times. And you've got, since it's the diameter is twice what a 50 millimeter is, you have 4 times as much light gathering ability, because the it goes by, I believe, the square for the area.
And here's
so
the
you're
size of my
gathering a
head.
lot more light with that. Of course, you're at a higher power, so you need a tripod, because the littlest movement, if you're holding it with your hands, would send it all over the sky. You couldn't hold it steady because of the weight.
Yes.
But with that, you should see, a lot of deep sky objects. Even though you can see an awful lot of deep sky objects with even like 7x50 binoculars. I've been using for many years my grandfather's old BU shipyard naval binoculars that are 750s. They're ancient, and they weigh a ton. I had to develop my upper arm strength to be able to hold them. But with that pair of binoculars, I can see like M51, which is a galaxy faced on spiral.
Yeah.
I can't see it super bright, but I can see it. And it's amazing what you can see in terms of deep sky objects. And I think real Messier marathons don't allow you to use a pair of binoculars.
That's
because
true.
you nail stuff too quickly.
That's okay. You can use, just to clarify, you can use binoculars for our little mini marathon. The whole point of this is so you go outside and look. That's all we want you to do. Go outside, look, have fun, and you'll see some stuff you'll try and you just get frustrated. Just move on to the next thing. So we don't want you to get hung up on
I think we
anything.
mainly picked objects that are visible in binoculars also, didn't we? So,
yeah, we did. And actually some of the ones we covered tonight are on here. So you can do like M93, and we covered a bunch of these before. So great. So somebody wanted to know, actually a bunch of somebodies, these are UberWorks. There are a lot of different companies that make them. I'm happy with these. As Kent mentioned, I can see a lot of great stuff. And this whole thing is like maybe 12 pounds. So I can just lift it up and go outside and I'm already ready to go. So it's like a 4.5 to 5 inch telescope. So I really enjoy it because it makes stargazing easy. So Kent, how long does it take you to set up your telescope? Your big one?
My 20-inch, about 45 minutes. Depending on where I'm setting up, like out in Navajo Flats, I have to park on the road and haul everything underneath the pipe fence that's running out there.
Yes.
Then jump the pipe fence and drag everything out into the field and start assembling it. So that takes about 45 minutes.
It does.
To get everything together. Then, since I've torn it down, I've got to recollimate the optics. So I've got to pull out my tools and get all the optics lined up properly, and line up the finder scope, and then I'm ready to roll.
Yes.
Where you can just haul this over the pipe fence and set it out in the field and bring a chair, and you're ready to go.
My chair. Yes. People have been asking this. My paper clip. Yes. And so I've already nailed 10 Messier objects, and you're still setting up. So that's the kind of lead I need on you for events, by the way. Okay, my chair. Yes, people have been asking about what is my favorite astronomy chair, and this is funny. They say, sorry, Brian. It looks like a giant paperclip, but that's because I can adjust the seat. See how it slides? And so...
that's really important, is being able, because of the height of the eyepiece will vary depending on where you're pointing the scope.
Exactly. So I know it's the most expensive chair I've ever bought, but it's like maybe 15 years old, and I've gotten a lot of good use out of it. So,
another thing that's really useful is a folding table.
Yes, a folding. Whoops.
I picked up a folding table at Thrifty's years ago. It was $10. They were getting rid of them, and that's that little table I use out there at the star parties, and it's so useful to put all your junk on, your maps, your charts. And you bring along some heavy objects that you can put on top so the wind doesn't blow the charts around.
That's true. You mentioned that your star charts are incomplete now because there's a page that's where did it go?
Yeah, my Sky Atlas 2000 when I was in Western Australia. I mean, it's really a beat up copy. I had the
Let me pull mine out.
You know, there's actually folds in the the main charts, and I used them so frequently the folds were ripping, so I had to take like Scotch invisible tape and tape up the pages, and the whole binding was coming out, so I had duct tape running. Yeah, this was the first edition.
Yes.
You've got a second edition.
Only but you would have spotted this. This is
an excellent star chart for an 8-inch scope. I mean, if you can flip open a page there, you can see it's color-coded. The galaxy is blue. The Milky Way lines are blue. Little galaxies are red. Clusters are yellow. And then planetary nebulas are green. So it's nicely color-coded. At the last page is a big overlay of where all the charts are in the sky. There, yeah, I can see open clusters. I can see a few galaxies. Okay. And it's nice, when you see the blue there, you know that you're in the Milky Way.
Yes. Here, let me get the last page open. There we go. Anyway, so which one are you missing?
Yeah, there's the overlay. It shows you where the charts fall in the sky. So if you want to go for Orion, you're looking at chart 11. If you want to go for Canis Major, you're looking at chart 12 to 19. And so that's really useful when you're wondering, which chart do I go for?
Notice he's just telling me what the charts are. He doesn't even have this in front of him.
There we go, chart 11. And
Perfect.
You can see the belt stars in there. It's really nice, but with an 8-inch scope, there's enough stuff to keep you busy for a long, long time.
Yes, they are, and they come laminated. They come all, and I think I saw one for sale for $900. So if you have one, and you don't use it, you could probably sell it. So there's another question. They're wondering, how do you observe the moon when it's so bright? So I don't know if you can see, Ken. I actually use one of these.
That's a polarizing filter.
Here, let me get it closer. See, now you see me. Now you don't. Now you see me. So it's like the two pairs of sunglasses, and we're doing this and they're both polarized. So this is the way I do it, but there are other ways to do it, like waiting until the moon is...
Actually, when I look at the moon with my 20-inch, it leaves an image on my eyeball. When I pull away, I can still see the moon.
Oh,
no. Because it's so bright in the 20-inch. If you're looking like at a full moon, which I'm rarely out there during a full moon.
No, yeah.
But that tends to be a problem. It totally destroys your night vision.
Yeah, telescopes are indoors when there's a full moon. So yeah, we don't stargaze there. Other questions are, what kind of filters do you recommend if you live in a city? So do you have recommendations? I'm pulling some out right now.
There's some light pollution filters that go after some of the frequencies that are given off by street lights. But to tell you the truth, I usually observe from dark skies where I don't have that problem, so I don't have a lot of experience with using light pollution reduction filters.
Yeah.
So that's what they're called. And
I don't think I've ever used these. Go ahead.
If you observe from a light polluted area, they probably do help. They're getting a lot better with the filters than, 40 years ago.
Okay.
In fact, about 40 years ago is when the first filters came out. Lumicon came out, I think, with the UHC filter first.
I have
then with the O3.
Yeah.
And, they ran about $100 for inch and a quarter filter. There's about $200 for a 2-inch filter.
Yeah, they're really expensive.
I've really put the miles on my, my O3 UHC and H beta filter.
Yeah.
Every planetary nebula that I would try and observe, I would use all 3 filters because there are a handful that are H beta, which is quite rare. And so, but I had to try. So
Yeah. Now, Brian, did you want to pipe in? Because I know you've got a filter, you've got experience, especially with astrophotography. Is there anything you want to add?
Let's see, what would I like to add? I guess I would just like to add one of the neat things once you start getting into astrophotography is there are filters you can use that will help block out so much of the light pollution that exists. Most of the street lights and such have very specific wavelengths of light that they put out. And so they've created some very nice light pollution filters. So once you start into that, then that'll be something to definitely look for. Is what will happen is it'll bring out a lot more contrast in your images. Now, because it actually messes a little bit with the color balance, I haven't been using them tonight. So mine was just a straight view through the telescope right into my camera. But moving forward, I'm getting what's called a filter wheel that actually lets you rotate through different filters, and I'll be able to show the differences as we go.
Perfect. Okay, Kent, one more question for you, I think, and then I'll answer one, and then Brian, look, I actually have one. So, so we all look geeky. The whole reason for doing astronomy is so you can get gadgets. And yep, we all put these on our foreheads at night, and this is how we see, and this is how we look. Oh, wait, if I got it upside down, I do. Anyway, so it goes on your forehead, and so this is that nail polish thing that Kent was talking about. You could just get one that has white light, which you'll get. I recommend not using the white light, but the red light is the one that everybody is.
Yeah, it's good to have the white light when you're packing up.
When you're packing up,
so
yeah.
You can see, what you're going after, and you don't stumble over anything. So, a white light at the end of the thing. You don't want to turn it on when everyone's observing.
No.
Because then you get a lot of angry voices.
Yes, you will. Other things, most telescopes will come with a finder, and very quickly, especially if you have a refractor, you will find this very frustrating, right, Brian? So when you look through a refractor, things are not as they seem. So getting to know your telescope during the day by looking at trees, by looking at the landscape is going to be very helpful. Looking at the moon can also be helpful when you start to shift into nighttime observing. And of course, disclaimer here, we're not looking at the sun through anything with lenses. Okay, so then there's also the Easy Finder, which is a laser, which puts a little laser dot on a little piece of glass in here. They make them bigger like Telrads and so forth, but you can easily swap this for this. And both of these are great. Yeah.
That one you're holding up, the regular finder scope, I think that's about a 6x30 or even smaller.
I think it might be smaller.
I don't know if it's got some numbers on it or anything like that, but
I don't actually
when I bought my C8, it had this dinky 6x30, 6x30 orange finder scope. And I got so frustrated trying to find anything.
Yeah.
It was the first accessory I bought was a 8x50 orange straight through finder scope.
Yes.
And that made a world of difference. All of a sudden stuff matched my binoculars. Yep.
Yeah.
If you have like the little dinky ones on a big scope, it's very frustrating.
Yeah, it can be really frustrating. So you want to upgrade your, let's see if I can get this, that camera's too far away. So I don't know if you can see it up here. This is a bigger one, so much better.
Yeah, that's probably, what is that, like an 8x50?
I think it is.
So.
Yeah, I think it is. And this one doesn't actually say, this one does. It says, yep, 8x50. This one is so cheap it doesn't even say. But anyway, so that's another good upgrade to get to your, and these usually, I think these were expensive, but now they're like $30. So just to get a laser finder or a bigger finder scope. And then when you get a bigger telescope, you use your current telescope as the finder for the next one, right? So you just keep getting better.
The one thing with the laser ones is that they don't magnify the field.
They don't.
And so you're dealing with, whatever's in the sky there under normal observing. That's what you'll have.
Yeah.
Where with an 8x50 straight through, you can actually see a lot of the deep sky objects you're going after.
Yes.
So that's the advantage of, even though it adds more weight. And there's the old Teleview. Yeah.
Yeah. Or the
My
Telrad?
telescope originally came with one of those.
Oh, really?
Yeah, and I'm horrible at using a Teleview. So
Those
I
are
ended up
Telrad.
Telrad, not Teleview.
Telrad, yeah, Teleview's the eyepiece.
Teleview would be
right,
like the
Brian.
nicest eyepieces I would ever buy. So,
So remember all those weights I put on the end of my 20-inch?
yes.
That's for my eyepieces and my finder scope.
Oh, gosh.
Is all those extra weights I had to put on the end to
That's
make
true.
up for the torque.
That's true. You know, I remember one of the first times being out there, I think you were out there, and I balanced the telescope. So, not so much important with this one, but like with Newtonians or so forth, mine was up on a tripod and I balanced it, and then I put the eyepiece and this on it and this on it, and I went to unlock it and the whole thing went whoosh.
Yeah, they'll take off on you.
They will. So you have to load up your telescope first, then balance it, and then you're good to go. But yes, getting to know your telescope indoors is best. You don't want to be setting it up at night when it's really dark. Other question is my favorite eyepieces. I'm sure, Kent, you have a very favorite eyepiece. Is that right?
Yeah, I have a really old one. It's a 1.25 inch eyepiece. It's a 32 millimeter Erfel that originally came with. I bought my C8 used, so I got extra goodies with it, and that was one of the It was a Celestron Erfel eyepiece, and it has good eye relief, and I found it was really useful for like blinking planetary nebula with the filters, and so that's like my favorite eyepiece for my 8-inch.
Wow, that's awesome. So my favorite, well, it's going to depend on what you want to see and what the seeing conditions are and what telescope you're using. So for me, these are, Orion didn't make these for very long, but they're called the super wide 65 degree lanthanum multi-coated. I like the 17 millimeter with an 8-inch reflector. I think the Vixen makes a similar one. I'm going on a limb now. That might be wrong, but everybody has their own preference. What I like doing is going to a star party and borrowing people's telescope. Wait, that didn't come out right. Borrowing people's eyepieces to put into my telescope, and then I can really get a feel for what will work and what won't.
That's a good idea. Yeah, I mean, I've heard those called grenades because of the weight and shape.
They're so heavy, but they're for public stargazing for kids is great because they're huge, and the kids.
They've got. In fact, what I use is remember that 32 millimeter.
Yes.
Teleview big honking eyepiece that I use. That's got a real wide field.
Yes.
That's great for star parties because.
Yeah.
One, with the wide field, it takes a long time for an object to move from one side to the other.
It does.
And then the other thing is that people get a nice, wide, low-power view of the object.
They do.
Then after I give them one view with that, I may pop in a 19 millimeter eyepiece so it'll give a more magnified view of the same object, depending on what we're looking at.
That's true. That's true. So we're going to wrap things up here. I do want to point this. Actually, I should use this as a finder. What do you think?
That would be a pretty cool finder.
That would be a good find. So this was, I don't remember why I purchased this, but it wasn't for stargazing. This is, we call these things door stops. This one's actually not bad. But in general, telescopes that are less than $100, like this one, they're going to frustrate you and they're going to turn you off to astronomy. And so I only keep this so I can point it out and say, and they'll usually won't have any brand names on there. You'll get them at Costco or Walmart. So if you like door stops, get one, but otherwise just walk away. So we don't want you to use telescopes like this. We would much, much rather you use a nice pair of binoculars. The ones that I pointed out tonight, these are $30 from Celestron. They're called Cometrons. They're 7x50. So if you want, these are great for kids because if they drop them and break them, it was only $30, and you really know now that you don't want to buy them a telescope. So for grown-ups, these are Orion Ultra Views. But as he said, you don't have to spend a couple $100 on binoculars. You could just get going with something that you probably already have, or you can borrow. And then once you're ready to do telescoping, you want to go to a star party and really get a feel for what you want, because what you buy is going to depend on what you want to look at, where you're located, what your seeing conditions are. So it's going to, you just don't want to go buy the biggest, well, that would be cool. to buy a big telescope, but you've got to keep in mind what it is you're looking at. That will determine if you're going to get a reflector, a refractor. For example, I wanted this one because I wanted to throw it in a backpack and go hiking. I didn't realize it was 90 pounds. I'm not much more than 90 pounds. So, and I actually got the backpack, but now I use it for other things. So there was a backpack that actually came with the mead, and it, like, the whole thing fit into it, but it's enormous, and it didn't look that big in the ad. So had I gone to a star party and seen this, I would have been, there's no way I can backpack that up a mountain. So now I know. So, anyway, so long story short, we hope you've enjoyed tonight's stargazing event. Kent, do you have any last words you'd like to share? Anything else with our audience?
Well, one thing, if I really was cornered to get a telescope, I would point someone towards a simple Dobsonian. They're the best bang for the buck, like an 8-inch one, 6 or 8 inches. You know, they don't have any fancy controls. They just go up and down and around on a lazy Susan, and you know, they're basically one tube, so it stays collimated. You don't have to like collimate it every time. They're easy to move around, easy to set up, and you know, that would be like the next step out from binoculars is go, there you go, there's a rough idea. That's actually a big one. That's like a 12-inch.
I think, Dave, is this a 10 or 12-inch? You can just let us know. I forget.
Yeah, it's a lot bigger, you know. An 8-inch would be fine, and they make some with the mounts are really, you know, it's a real simple mount. There's no tracking. You can't do photography, but you can learn a lot with one like that.
Yeah.
And so, you know, that, and they're cheap, you know, relatively. You'll get, you know, the most aperture for the least amount of money.
Yes. And that's a 12-inch. Thanks, Dave. So it's a 12-inch.
Okay, so that's
right.
Yeah, that's a biggie. And they make 8 inches, and that's called a Dobsonian mount. Actually, it turns out at pawn shops and sometimes in like easy ads or things like that. That's where I got my C8. In an easy ad thing. And if you can find, there's lots and lots of the C8s out there.
There are.
You know, but definitely you want to look through it and make sure the optics aren't messed up.
Yes.
But in fact, I took it out before I bought it, looked down the street at an insulator way on a pole a long ways away, and the insulator came to wonderfully sharp focus. So I decided I wanted to get that old C8 that I got. And so those show up every so often. I remember there was one at the pawn shop here in Atascadero for $400, which was a bargain for one of those. I mean, and it had lots of goodies with it. So,
nice.
You know, but actually the best bang if you're buying something new, you know, go for a Dobsonian, like the one you showed with Dave there.
Yeah.
Except the smaller size.
Smaller size, 8-inch, totally fine.
An 8-inch would be fine. You know, 8-inch you could use for a decade.
Yes.
Before you decide, you know, learning the sky and going after stuff.
Okay, great.
But
where are the binoculars? Okay, sorry. Go ahead.
Yeah, after you've paid your dues, then you'll have a good idea what sort of monster scope you want to get. Or if you want to do astrophotography or that sort, you know, some crazy thing. It's just don't get rid of your old scope. You know, you may decide that the monster thing's too big, or you know, astrophotography is too much work, and you always fall back on your old scope.
That's true. Well, guys, we're going to wrap it up for tonight. Kent, thank you so much for sharing your expertise and inspiring us to go outside tonight and look up and really knowing what we're looking at. So thank you, Kent.
Oh, you're very welcome, Aurora.
Thank you. And Brian, I want to say thank you to you as well. Thank you for braving the cold and polar aligning.
You're welcome. My pleasure.
And everything. So, and thank you all to the astronomers from Central Coast Astronomy for helping us out answering questions tonight. Again, my name is Aurora with Central Coast Astronomy. We invite you to subscribe subscribe to our channel. Check out our website, www.centralcoastastronomy.org, and go ahead and you can get on our email list. We will send you an email when we are doing our next ones. You can also subscribe to our channel and hit that bell. That will turn on your notifications for when we go live. You'll get a little bling, and then it will, bling wasn't the right word, but you'll get a thing that will tell you that we're live. And we are looking forward to seeing the work done by you for the Messier Marathon. And thank you so much for supporting our club and sharing it with others. So tonight, go outside right now, look up, see if you can find Sirius, see if you can find some of those things we mentioned. You can rewatch this on our website, which is www.centralcoastastronomy.org. You can just simply look for the date, and you'll be able to rewatch this as many times as you like. All right, everyone, have a great night. Goodbye. Goodbye. Bye, Brian.
Goodbye.
Bye, Kent. Thank you.
See you later. Bye.
Goodbye, everyone. We'll see you all real soon. Take care.